Here we're going to continue the introduction about the image scene, and we already talked about the structure of this tool. And in your homework, you are going to use this tool to do some STD-MRAN array level design. So for you to better understand the code, so the following will be the quick tutorial. And here we're going to see some sample files from the tool. And this one is the configuration file. And in this configuration file, you're going to define some of the targets you may want to optimize. You can do that. And also you can choose the technology node. And also you can define your memory capacity you want to design. And if it's for cache, you can also define this associativity in the cache. And then the device technology, like high performance, no standby power. So then also there are some options you can choose. I don't know the details of those. And this is for interconnect. And then you can also define the routing, like H-tree, internal sensing. That means the sense sample is located at the edge of the array. So then you should note in the memory cell file where you define the memory cell characteristics, like the write voltage, write latency, or the read voltage, and then the resistance on and off states. So I think those parameters are defined in this .cell file. And in your homework, you are going to modify this std-run cell. And then you can run the simulation at different temperature for the chip. And then the buffer design choices, as we discussed, you can optimize for latency or area or have a balanced design. And then here is the higher level, how do you organize the bank into how many match, and match organized into how many subarray. And then this is what you can modify. And then the max sensing sense-amp. So this is how many columns to share one sense-amp. So you have those parameters you can modify. But you may not need to do that for your homework. If you use this tool for other designs, then those are the parameters to modify if you want to change the organization of the bank. And then if you look at the sample std-run.cell file, this is one file to be loaded in. So this defines the memory characteristics, like the cell area in terms of the f square. And in this example, it's like 57 f square for the STD-MRAN, as we discussed. So the transistor W/L may not be what you need to size up to have enough current to program the STD-MRAN, so you have larger cell area. And then the on and off resistance, and those like read and write voltage, set and reset, voltage or current, so those parameters. And the access type, CMOS, that means it's 1T, 1R cell. So those are the parameters. And basically the input to the tool will be those two files. One is configuration file to define the high-level organization and the peripheral circuits choices. And then the cell file is going to define the memory cell characteristics. And then you use those two as input and then run the simulation. And then you get the output. And here is the sample output format. So it will print out for you those information. First, I think it will repeat your input assumptions. So here will be the same as your input. So basically repeat what you have input for the cell level parameters. and then your design specs. You are going to design, for example, in this case, 128 kilobyte cache. And then this will repeat your configuration. So it's just repeat the configuration you defined. And subarray size, for example, here 512 by 512. And then it will followed by the real results. So this is the result. And it will give you like the area, total area, in terms of the micrometer. And then it will break down the area into the mat level and the subarray level. So you know the size for the mat and the subarray, and also it will report the area efficiency for the whole bank. And the timing, in terms of the latency, for read operation, this is total, and then it will also have breakdown into different components, like in the routing, H-tree latency, and then what is the latency for accessing the mat. Within the mat, you are going to will have those decoder for that mat, and then subarray level, and within the subarray level, you have those decoding bit length, and max latency, and so on. So you can see the breakdown of those metrics. So that's for the simulator. So any questions?
So we optimize for a specific target. What are the parameters that's changeable, like variable, that you can search through the space? What are the?
So like those input parameters, you can change, for example, the array size and the technology load or the buffer type, right? So those are the parameters you can change.
But I think once we run it, it's already fixed. Right?
Yes.
But
unless you modify the configuration file.
Yeah,
right?
but your configuration file also has a target, like an optimized target for area or for EDP.
I'm not so sure. Yeah, I didn't
okay.
run that.
Okay.
Yeah. But I think if you just give one set of parameter, of course it will give you only one result, unless there is something you can sweep.
Yeah.
Right. Sweep the parameters. Let's say array size from 32 to 512. And then it will run multiple simulations, and then it will pick maybe the smallest latency for you if you optimize for latency.
Yeah.
But you can manually do that.
Yeah.
Right. You can manually do that. I don't know if that auto function is working or not. Yeah, but you can manually do that. All right.